This is the second question of the unit test. The goal is to find whether or not this table has a linear relationship. And a linear relationship is dependent on whether this distance is constantly increasing by the same amount for every 1 second. Now we notice the seconds are kind of jumping around. They're not going up by 1 every time, and they're not consistently increasing by the same amount. And we notice it with this here too. They're not constantly increasing by the same amount. But we can find the difference between each distance and find the difference between each second and determine a pattern. When we go from 11 to 17, that's a difference of 6. When we go from 17 to 25, that's a difference of 8. When we go from 25 to 9, it's a difference of 4. And we go from 29 to 31, that's a distance of 2, or a difference of 2. So we find these differences and they don't look like they're the same, but that doesn't mean anything yet because these times aren't the same as well. That's not increasing by the same amount. So we're going to go from 0 to 3 seconds, that's a change of 3. In order to change from 3 to 7, that's a change of 4. To go from 7 to 9, that's a change of 2. And to go from 9 to 10, that's just a change of 1. So that means in 1 second, it changes by 2 meters. In 2 seconds, it changes by 4 meters. In 4 seconds, it changes by 8 meters. And in 3 seconds, it changes by 6 meters. Now, right now, it's kind of hard to tell exactly what's going on, right? Well, what we can do is find the ratio of the difference in the distance to the difference in time. And we could do that by dividing. So 2 divided by 1, that's 2. 4 divided by 2, that's 2. 8 divided by 4, that's 2. And 6 divided by 3 is 2. So we find the ratio of the difference in distance and the difference in time. We find out that there is a constant change, and it's of 2. So for every 1 second, it's changing by 2 meters. So yes, this is a linear relationship because there's a constant rate of change. It's constantly increasing by 2 for every 1 second. So in order to write our equation, remember, in order to write our equation, we need to use the form y equals mx plus b. Well, m, that's just our rate of change, or our slope. We found our constant rate of change. Our constant rate of change is 2. And our b, or our y-intercept, is found on our table. When our time is 0, what is our distance? And that gives us our b.